hours per year, still the 11 cents per kilowatt hour, and then all different flows within the system, what the VFD is doing, and your percentage of using them. In the meantime, if you notice, the majority of your efficiencies now, one far end, you're not getting it as efficient, but you're still getting the demand and only using what's actually needed within the system. So you have your percentages, so it's using 100% of the time, and it's more or less calculating how many hours it's being used. So within that, down here at the bottom, kilowatts per hour at full speed, that's how many kilowatts, and cost per year, it's roughly running you right at $35,000, and you put a VFD on it, that's costing you roughly $34,000 per year. So per season, just a quick math, it's saving you $358 within the season just because of VFD, and it's only meeting your needs to what your needs are. Sizing and consideration for a VFD, it's pretty simple to a common system. One thing that you want to look at as far as find the pump first. If you have an existing unit that's oversized, you can work with your pump man and so forth, and we can work out whatever we need to do to help you out. But one thing you want to do, you can't just say any pump can go on a VFD and you're just it's going to put tons of money in your pocket. That's just one thing you need to work with your pump man, and he can help you out with that. Also, calculate your maximum brake horsepower, what's going to be used, because one thing that these are very particular on is amp draw. So therefore, you want to make sure it's sized properly and make sure you don't oversize, or if you don't undersize it, because you could possibly hurt a motor and or your drive at the same time. Submersible applications, you need to double check your service factor amps, because the amp draw on a submersible motor is a little bit different than your standard motor, above ground motor. And also setting your minimum frequency to 30 hertz. There's many different reasons to do that. As far as 30 hertz as a whole, typically you're not moving much water anyway, so therefore if you set it below that, all you're doing is creating heat in your motor, and that's not very good for it. And then also, when you select a VFD, make sure you have the maximum amp draw rating, as I mentioned earlier. And also, make sure your enclosures, you can't just put an everyday drive if it's not sized properly. You can't just put it out there and expect it to run throughout the whole system. It's kind of like putting a brand new refrigerator outside and expect it to withstand all the elements outside, as far as whether it be snow, rain, anything else, because it's an electrical component. When you're sizing it, as mentioned earlier, you want to size it typically 10% of your best efficiency point. And typically your best efficiency point, you really can't tell on this, is typically in the center, and you have more or less your biggest potential for a VFD. So you want to size at 10% of your best efficiency point. So if it is when it is, say, a little bit oversized, what you do when you put the VFD on, when you slow it down, as I mentioned earlier, the efficiencies follow the speed of the motor. So therefore, even if you do get a little wear over the time, it pulls it back into your best efficiency point, so you have a long-term efficient system. And I got a little bit ahead of myself right there. And as I mentioned earlier, as far as setting your minimum frequency to 30 hertz, not only because you're not getting much production out of it, but on submersible motors, you want to double check that, because how the submersible motor is designed, after 30 hertz, it's required 30 hertz as far as the speed to keep the lubrication between your Kingsbury bearing, which holds your thrust of your motor. So you want to make sure that you keep it to a 30 hertz minimum at all times. Many different benefits as far as this. As I mentioned earlier, VFDs are by far the fastest growing item that I know of from my side of the industry that I've ever seen in the agriculture or irrigation side of the business, because it not only does it save money, but it more or less gives your best bang for your buck, as far as it provides the proper water or proper pressure for your system. As it was mentioned earlier, as far as uniformity within your system, if you have the proper pressure throughout the whole system, you have a better chances, or more likely to keep uniformity throughout your crop. As I mentioned earlier, energy savings, you match performance with demand. You can do variable applications, reduce voltage as far as starting, as mentioned earlier, You can use it as a phase converter. One thing that we talked about as far as phase conversion, there are certain people that are in certain areas that are using this for phase conversion. So if you have single phase power, what that is, you have to derate the drive, and it's a cleaner way to provide electricity to your motor, which it's a lot better in the long term because it does know the factors of what a motor needs and doesn't need, and it will not more or less premature failure on your motor, and it is energy savings going to a three-phase application as well. Motor protection, more or less longer well life, so you're not putting as much stress as possible on that well going full speed. And what it does, it only uses what it actually needs to have within the system, what you program it for. Reduces wear on the pump. It's self-diagnosing. Typically, the drives are more or less have the technology. As mentioned earlier, technology is a very large thing, and that's one thing that you want to look for as far as it's self-diagnosing. It tells you if the pump's pumping off or if it's getting underload as far as your amps coming to the motor or overload to make sure you don't fry a motor in the process. There's many different factors in there. And that has a built-in fan as far as the majority of them. So because there's a proven thing in the hot time, prime time summer, if this is out on the middle of a pole, this has a fan to cool it down because it's proven with the drives, or any electronic component for that matter, anytime it starts overheating, it derates the performance. So it'll derate the performance going down to the motor or the electricity going down the motor, and it slows it down and you're not getting your uniformity as talked about earlier. At this time, thank you very much for your time, Steve, and I will jump up here if there's any additional questions.
I'd like to take just a moment and tell you a couple of things and hit on some stuff that Rodney has talked about. The producers, when you are looking at replacing a well, or if you're looking at doing a new well and you want to look at some of this technology, ask your dealer or your driller, whoever's going to install the pumping system, for a copy of that curve and look at your efficiencies and make sure that they're the most efficient pump out there on the market. Compare, get pricing from other people, look at it, but get the most efficient unit. Anytime that you can take this one unit and combine it with a VFD drive, which has all of the features and benefits, will make your system even more efficient. And along with that, look at your friction losses. The pump and the drive or the starter is not the only part of it. You've got friction losses to overcome. That takes horsepower. Okay, bear that in mind. Get with your dealers, your pump installers, and they can size a pump that'll fit your need. At this time, I think we'll ask for some questions.
One of my concerns, or one of my questions, I guess, is the VFDs that I've seen look like just computer panels. Do we need to be concerned about surges coming down the line damaging those panels?
Okay. The actual VFD drives do not like power surges. Do everything in your power to put something before it. Lightning arresters, buck boost transformers work real well. Anything you can do to help prevent it. Now, if it takes a direct hit, usually nothing can stop it. But for the most part, use lightning arresters in the system. Now then, along with what Rodney had to say earlier, when you're looking at these pumping systems and you're going to plan on putting a drive out there and you're putting it in an enclosure like a NEMA 3R, if you're replacing an existing system, leave your pump panel there, your across the line start, because you can take it right out of there, out of the drive, and put it into your across the line start and keep running for a little while till you can get the unit repaired. Does that answer your question? Sir? Okay, as far as the cost on these units, it depends on what you've got and what you size. There's a wide range of drives They can go from very, very simple, where you're flipping a couple of dip switches, all the way to, it takes a half a day to program them. Anywhere from a half horse all the way through 500 horse. There's a large variety of them. Can range anywhere from $1,000 up through several $100,000. It just depends on the application. But as far as overall, compared to across-the-line starts, they are going to be a little bit more expensive, but with the energy savings that you have, it will actually pay for itself in a very short period of time.
What are you seeing typically for a service life on the VFDs in the Panhandle? 3 years, 5 years?
I have actually got a set of drives. It's actually on a three pump system out at Lake Ransom Canyon. They're in Lubbock, and that's going on 11 years now. And we've had one failure, and that was due to a power surge. Also, while I've got your attention, there's a lot of things that you can do with a drive. If you get one of the ones that it's programmable, you got a lot of features and benefits as far as motor protection. There's also dry contacts in these. So anytime you have a system where you have to have control of that from a pressure switch maybe, or a float switch to control a level in a tank, all of that's available already in the drive. You don't have to add to it. All you got to do is put a float switch in it.